Welcome to this 11 plus verbal reasoning masterclass. Here we're going to be going through word pairs, which is one of the harder question types that you're going to encounter when you open your exam paper. Now, this question type doesn't have to be hard. So here's my promise. If you watch this video all the way to the end, and you take in all the frameworks and methods we're going to go through, then you will get this question right every single time. So if that sounds good, let's get straight into this masterclass. Okay, so when it comes to answering word pair questions, there is a framework that we have to use every single time. Now, this special framework has two steps. The first step is we need to start with certains. And the second step is to create a code. Now, to understand this, let's really break down this question type and what's being asked of us by the examiner. We have three pairs of words. So we have our first pair of words, we have our second pair of words, and we have our final pair of words. For our final pair of words, we have to work out this word in red. So we know that for each pair of words, the word over here is made up somehow from the word on its left. Same thing here. This word over here is made up somehow from this word on its left. And we need to work out exactly how these words are made up and then apply that to our pair of words. This will give us our answer. So starting with certains simply means identifying when a letter on the right side can only come from one place within the accompanying word. And creating a code is what we do when we have a letter that could come from more than one place within the accompanying word. So if we have a letter that could come from more than one place, then we need to create a code. Let's say that letter could come from position 2 or 4. We can write down 2 or 4. And then this means when we come to our second set of words, our second pair of words, when we reach that same position, we may find out that this letter can only come from position 4 or 6. And now you can see that by creating a code of where the letter comes from when it's not certain, we can now see that the letter must actually come from position 4 for our answer, because our first pair tells us position 2 or 4, and our second pair tells us position 4 or 6. So 4 is shared, and therefore it must be the real position. So let's see how this works on some questions. Okay, so let's go through this question. We're told in the following question, there are 3 pairs of words. Find the missing word that completes the last pair of words in the same way as the other 2 pairs. So in the same way is in bold, really important. And we're trying to work out what should go over here. So remember our framework. Start with certains, create your code when we can't work everything out with certains. So there are varying levels of difficulties when it comes to this question. And this is the easiest one. Sometimes every single word, or every single letter rather, will be a certain. So here we know that last is made somehow from blasted. Ramp is made somehow from cramped. But if we go a bit deeper and look closely, we see that every single letter is a certain. L only comes from this L over here. It's a certain because it can only come from position 2. And therefore we're going to use this to work out what our first letter should be. And that should be V. Position 2 of avoided. Same thing with A. A is a certain. It comes from position 3. So now we want O. S, certain again. We want I, and T, certain again. This is the easiest level of difficulty. D. And we can see the same things repeated over here. Ramp is pretty much seen right here. We can copy it straight across. Our answer is void. But now let's see when it gets a bit more difficult. Right, so here we have 3 new pairs of words. We have hang, made up somehow from hanging, meal, made up somehow from medical, and we need to work out what to put over here and what letters we should take from optical. So starting with H, we actually have a certain in H. H can only come from one position, and that is position 1 from hanging. So therefore we can move across to optical and see our first letter should be O. And then we have A. A is another certain. It can only come from position 2. So now we can apply this to optical, and our next letter should be P. Then we have N. Now N is not a certain. We can see that N can come from 2 positions. It could come from position 3, or we can count it. It could come from position 1, 2, 3, 4, 5, 6. So it's 3 or 6. So you can see we create a code, and we'll come back to it later. Then we have G. G, again, we need to create a code. It's not a certain. We're not certain where the letter G comes from when we look at hanging. It could come from position 4, or it could come from position 7. So 4 or 7, here's our code. Second step of our framework. So now let's use this second pair of words to try and work out what's going on. We don't care about M and E. We've already worked that out. But let's start at A. Well, we can see that actually, although N was not a certain for our first pair of words, A is a certain for our second pair of words. A can only come from position 6. So now we can see that N must have come also from position 6, not position 3. This second pair of words helps us to solve this problem. And therefore we're certain that our third letter must also come from position 6. And that is A. So let's put in A right here. So now let's move on to L. And L again is a certain for the second pair. We see that L can only come from position 7. And therefore this means that the G from hang must have also come from position 7, not position 4. And therefore, if we use that and apply it to optical, we know our fourth letter should be L, the 7th letter of optical. And our answer is opal. Now let's try and go one more level higher again and see what happens when we have more uncertain letters. Let's go to our next question. Okay, so here we have our next question. We have inanely and nine, abandon and banned, and then adorned, and the answer we need to work out. So we always go back to our framework. Everything starts from the framework. Step 1, we start with certains. Step 2, we create our code. Let's see how that framework can help us in answering this question. Well, if we look at N from 9 and we look at inanely, straight away we see we do not have a certain. We need to create a code because N can come from multiple places. N could come from position 2 of inanely or 4 of inanely. Then we have I. I is a certain. I can only come from position 1. So let's fill that in. We know our second letter. So if we have 4 letters, 1, 2, 3, and 4, we know for our second letter, it's going to come from position 1. So let's fill that in. That's going to be A. Now let's move to our third letter. We have N again. Well, it's going to be the same story. It's either going to come from position 2 or position 4. So we create our code. Then we have E. E is a certain. Great. We love certains. Let's count which position it is. 1, 2, 3, 4, 5. So now let's apply that certain to adorned. 1, 2, 3, 4, 5, N. Our fourth letter should be N. Now we're going to use this second pair of words to try and sort out and work out what's going on. So let's start with position 1. Well, now we have a certain, great, because B can only come from one position. And that's this second position right here, this second letter right here of abandon. So we're going to apply that to adorned, and we see that gives us D. So D is our first letter. Now we only have one letter to go. We need to work out where this third letter comes from. So N of band. Let's create our code. We can see it can come from more than one position. So N can either come from position 1, 2, 3, 4, 4 of abandon, letter 4 of abandon, or letter 5, 6, 7 of abandon. So we're creating our code, second step of the framework. But now can you see something? Although we have two codes, one code for N here and codes for N over here, we can actually use these codes to work out the true position of the third letter. And that's because we can look at the first pair of words and we're told the third letter, N, either comes from position 2 or position 4. But then for our second pair of words, we're told the same third letter can either come from position 4 or position 7. So can you see the position in common? It's going to be position 4, letter 4. The first pair says 2 or 4. The second pair says 4 or 7. So it has to be 4. And therefore we can apply this to adorned. The fourth letter is 1, 2, 3, 4, which is R. And therefore we want R as our third letter. And we've worked out the entire word. It's going to be darn. Now, another way we could have worked this out is when we took a look at B for our second pair of words, we worked out that B was a certain, as it can only come from letter 2 of abandon. So therefore we know that the first letter of our answer should come from position 2. And therefore we can use this, or we could have used this, for our first pair of words. Because we were unsure whether the first letter, N of 9, came from position 2 or 4. But now, because our certain B has let us know that actually the first letter comes from position 2, that means we know that the first letter of 9 is 2, or position 2, and the third letter of 9 is position 4. So we could have worked it out that way instead of using the similarities between both codes. But either way works. The main thing is we use our framework. The first step is to start with certains. This helps us get a lot of easy wins. But the second step of the framework is we create our code. So this brings us to the end of this 11 plus verbal reasoning masterclass. Make sure whenever you're faced with the word pairs question type, you use the special framework. Start with certains and then you create your code. If you do it correctly, you will get this question type correct every single time.